right? So this is module 2, 2016 paper for Pure Math Unit 2, right? A sequence is defined by the recurrence relationship, and this here is the recurrence relationship. You have u subscript n plus 1 is equal to u subscript n minus 1 plus x by u subscript n prime, where u1, the same, is equal to 1 and u2 is equal to x. And u subscript n prime is the derivative of u subscript n. Okay, cool. Everything fine there? Read the question. We have, for example, and so they're giving us an example of what taking place with regards to this recurrence relationship, right? They're saying that u3 is equal to u2 plus 1 is equal to u1 plus x by u subscript 2 prime, which is equal to 1 plus x. So basically what they did here, they're taking this particular relation here and they put 2 here, right? And that's how they get the u3. And they put the 2 here, and that's how they get the u1 here. And they put the 2 here as well, and that's how they get this. And yeah, basically u1, they stated u1 is equal to 1, so they replace u1 with 1, so that's how you get this one here. And then the u2 prime, right, is equal to the differential of u2, which they told us is x, right? So we're just looking at the example that they gave us, because this example is really important and just trying to understand what taking place, right? So now, what is the question asking us? That's what we need to know now, or we try to find out and try to, yeah, that's what we need to find out. What is the question asking us? It says, given u8 is equal to 13x plus 1 and u10 is equal to 34x plus 1, find u9 prime. So that's what we need to find, right? The first thing I would do is put down all the information that they gave us, that the question gave us. So let's do that first. U subscript n plus 1 is equal to these two things, right? So this is the recurrence relationship. They told us these things, that's cool. And then they gave us the u8 is equal to 13x plus 1, and the u10 is equal to 34x plus 1. So we have to use this recursive relation or the recurrence relationship to find out what is this u subscript 9 prime. How do we do that? I am thinking probably use the recurrence relationship, right? But what value could we use? That's what we need to try to think about. And the value I'm thinking is you have u10. So to get u10, we could substitute 9 here, and we could substitute n as 9, right? And we would get u10, and here you would get u8, because 9 minus 1 would be 8. And then here you would get u9, right? And then you'll be able to make some substitutions. But I'm just talking here. Let me put it down and you'll actually see what it is I'm talking about, right? So this is what I'm saying here. Let's use the recursive relationship when n is equal to 9. And what it would give us is it would give us this, right? Here, this is the recursive relationship. When n is equal to 9, you substitute it into this. That's what I did here. And what I have is this. You're seeing u subscript 9, or rather u subscript 10 is equal to u subscript 8 plus x by u subscript 9 prime. So this is what we get in. But when you look at it, right, you're seeing terms that they gave us. Remember, they gave us u subscript 8 and u subscript 10. Look, we have u subscript 10 and u subscript 8 here. So we could actually substitute those things that they gave us into this equation here. So that's what we will do next. And watch, it just set up really nicely here. U subscript 9 prime, which is what they're asking us to find. That is, well, we could just make that the subject of the formula, right? And we could solve for what it is. That's what we're doing next. So let's do that and see what happens. Let's substitute the values for u subscript 8 and you subscript 10 into this here, right? And see what we get. This is what we get in here up to this point. So it's looking nice. All we have to do now is make this here the subject of the formula, because remember what the question asks us to find u subscript 9 prime. So that's what we do next. We make u subscript 9 prime the subject of the formula. And this is where the question really boils down. It's simple stuff here. And in the end, this is what you get. When you manipulate it, we get u subscript 9 prime is equal to 21. Right? When you make it the subject of the formula, you see the x's that was given for u subscript 8 and u subscript 10, they come out, right? Or they cancel out. You would see they would cancel out here and here. And you're just left behind with 21, and that is your u subscript 9 prime. And this is easy 4 marks, easy 4 marks, and that's it. You collect a 4 marks and you go up the road, right? So that is the first question, or the first part of question 3 completed there. Now we want to look at the second part. Let's look at the second part now. This is part B. So we have part B says the nth partial sum of a series S subscript n is given by this here. Okay, cool, nice. What they're asking us to do is to show that the formula for the nth term for this n partial sum is given by this. That's basically what this is asking. They're saying to show that S subscript n could be given by this as well, right? And this is the formula, or the formula for the n term, or the formula for the sum of the n terms for this particular n partial sum. So that's what this is basically saying. So how we would approach it, we will need to use this here. So let's start off with putting down that, right, the formula. So we require to prove this, or rather show that. So let's start showing it. We have S subscript n is equal to this here. So when I look at that, the first thing I would do is I would multiply the r by this r and then the -1. And that will give me this here. So that's good. But then the next thing I need to do is utilize the formula. Rather, there are not formula, but the summation rules, right? There are summation rules which state that the summation, right, of sums or differences, you could bring the summation under this term and also this term. So basically the law is this. The sum from r is equal to 1 to n of, let's say I have VR plus UR, right? We could rewrite this as the sum from r is equal to 1 and VR plus the sum from r is equal to 1 to n of UR. So that's basically the law being, we need to apply that law here. So let's apply it and see if things could be made a little bit easier, right? So we apply it here and this is what we get. That's cool. But then now, when you look at these two things, they should look a little familiar, right? The sum from r is equal to 1 to n of r squared, right? That should bring up some memories of some stuff. Give me 1 second, right? So that should bring up some memories of certain stuff, right? You should know these formulas by heart, right? The sum from r is equal to 1 to n of r squared. You should know that formula by heart. And also to this, the sum from r is equal to 1 to n of r. You should know. These are basically summation rules that you should know. I would advise that from the time you see this, you should apply this here. This is what you need to apply here. These are the rules governing the sum from r is equal to 1 to n of r squared, and the sum from r is equal to 1 to n of r, right? And once we have this here now, it's really simple. It's just a matter of applying the LCM, bringing them under one fraction, and then just reducing it and simplifying it so that we could make it look like this here, which is what they're asking us to simplify, or to show rather. So that's what we do next, right? Find the LCM at 6. and it's just a matter of factorizing the numerator. And when we factorize out the numerator and break it down here and here, and we simplify it, right? What I did here in this line here is factorized out the 2 here, right? When you factorize out the 2, you get this. But what you notice here about this, n plus 1 by n minus 1, that looks very familiar. That's the difference of 2 squares, right? So that's the next thing to do. Convert this, right, from n plus 1, right, multiply by n minus 1 to n minus 1 whole squared, right, using the difference of 2 squares there. So this is what you have here, and it looks a lot like the answer that they asked us. It looked exactly like the answer that they asked us to show. So that's basically that, and this is a whopping 7 marks. Couldn't believe it when I saw it, but it is 7 marks. It's actually an easy 7 marks to get. The key things with this particular question is to remember, right, the summation laws, and also to the rules that govern these two. You see this here? Yeah, you need to remember those. So that is what you need to remember. And just want to check, right? Those are just some standard results that you need to remember for summation, right? Those are the formula for the sum of the n terms, where you have the formula for the n term is r squared, and the formula for the n term is r, right? So that gives you the sum of the formula for the sum of the n terms, right? Where the formula for the nth term is r squared and r. So that's key, right? So learn those results. Once you learn those results, this question is pretty straightforward, and the laws as well, right? The summation laws. And that is basically it. And we almost finished here, guys. We just have to look at the next part here. So let's look at this. They're saying hence or otherwise evaluate, right, the sum from 10, right, to 20 of r by r minus 1. So that's what they want us to do next. But remember, r by r minus 1, right, the sum from r is equal to 1 to n. We looked at that already. So we have like the formula for the sum of the n terms for it from the last question, right? Let's work out this now. The question is, how do we work out this? And we have to be careful. We can't just find from 1 to 20, right? What it is saying is basically it wants to find the sum of the terms from the 10th term to the 20th term. That is what the question is basically saying. So we need to rewrite the formula, or make sure we have the correct formula for this. This is the relationship that I recommend everybody to use, right? You find the sum of the terms from r is equal to 1 to 20. From r is equal to 1 to 20. So that is basically the sum of the first 20 terms. Okay, cool for the particular series. But that is not what the question is asking us. It's asking us from 10 to 20, right? From the 10th term to the 20th term. They want all the terms, the sum of all those terms. So it's basically like this. You have, right, 1 to 20, right? You're finding the sum of all the terms from 1 to 20. But the question isn't asking for that. The question wants from 10 to 20. They want this region from 10 to 20. So how do we find 10 to 20? What we could do is, as I have here, find the sum from 1 to 20. And then what I could do here is find the sum from 1 to 9. And I can find the difference between those two. And the difference will give me the sum from 10 to 20. Right? So that's what I have here. I found the sum from, or the sum of the first 20 terms. And then I found the sum of the first 9 terms. And I minus those two things. And that would give me the sum of the terms of the 10th term to the 20th term, the sum of all those terms, right? And that's basically it. So we're almost done here, and it's just a matter of also to using the information that we got in the first part, right? So that's what we need to do. Recall this information, right? The formula for the nth term of this particular series, right? The sum of the n terms. So this particular series is given by this. We found that in the first part. So all we need to do now is just, in the case of this, plug in 20 here, wherever you see n, to get this sum. And then in the case of this here, you plug in 9 into this. So that's how we get those two sums, right? So therefore, this is what we need to do. Plug in those two things, and it's just a matter of plugging it into your calculator, and you should get the answers that you're looking for, right? This will be the answer. Check it out on your calculator, plug it in. So you plug in 20, right, into this formula that we got in the previous part, and you plug in 9 into this formula as well, right? And this is your final answer, and that's it.